Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 13.2 entitled Finding Probabilities Using Permutations. And today we're going to use the counting principle, and we're going to use the formula for the number of permutations, and then we're also going to find the number of possible arrangements for an object, or a bunch of objects, I guess I should say. So let's talk about what an actual permutation is first. This is an arrangement of objects in which order matters. So this is like you have 3 pictures that you want to hang on your wall, and you can't all hang all of them in the same spot. So you could maybe hang one on the far left and one in the middle and one on the far right. So order matters. The order that you put the pictures in determines the different display that you would have on your wall. So let's just talk about that in terms of numbers here. Let's just call those pictures A, B, and C. So we could hang picture A first, and then we could hang picture B, and then we could hang picture C. Or we could hang picture A first, and then hang picture C, and then picture B. Or we could hang B first, and then A, and then C. Or we could do B first, and then C, and then A. Or C first, and then A and B. Or C, and then B, and then A. So those are our possible arrangements. And there's 1, 2, 3, 4, 5, 6 possible arrangements. Now, there's a shorter way to calculate this. Instead of drawing out all of the different arrangements and all of the different permutations, we can take the choices for the first letter times the choices for the second letter times the choices for the third letter, and then we'll get our actual total. So in my first spot here of my letters A, B, and C, or we were thinking of them as pictures, I have 3 options for that first spot. I could pick letter A, or letter B, or letter C. So I have 3 options. Then once I hang one of those pictures, then I've got 2 left. Okay, so it could be B or C. But then after I've hung the first 2 pictures, then I've only got 1 option left. So if I do 3 times 2 times 1, I'll get a total of 6 permutations. Okay, so we're going to use that equation, that type of thinking, to help us figure out permutations for a variety of different situations. So in example 1 here, it says, in how many ways can you arrange the letters in the word mouse? So you don't actually have to write it out in every single arrangement or permutation that we could have. We just need to count how many letters there are. So in the word mouse, there's 1, 2, 3, 4, 5 letters. And then we can use this equation for the number of permutations. So we'll basically take 5 times 4, oh my goodness, 5 times 4 times 3 times 2 times 1. And we'll multiply those all together and use your calculators if you need to, and you'll get 120. So there's 120 different ways that we could arrange the letters in the word mouse. I don't want to do that by hand. I don't want to write out the letters for mouse 120 different times and then count them all up. This is way faster using this little equation. So then in example 2, you're planning to visit 4 stores on a shopping trip. How many ways can you visit these stores? And this might be somewhat real world. You know, on the weekends you might go run errands. And so here we've got 4 different stores that we have to go to. So you hop in the car and you pick a store. There's 4 options for that first stop. Then after you've gone to that store, you're not going to go back to it again. Hopefully you got everything on your list. So you've got 3 options for the next stop, and then 2, and then your final store is left over. So again, if we multiply those all together, you'd have 24 different combos. And again, I don't want to draw a big map with 24 different paths for how we can go to all these different stores. We just want to do that easy calculation to figure out our number of arrangements, our number of permutations. Now, this type of calculation where we're doing a number times all of the numbers that are smaller than it, this is called factorial. That's what they call that in math, when you take a number and you multiply all of the numbers less than it together. So n factorial is the product of the positive integers from 1 to n. And we're going to write that as an exclamation point. So 4 factorial is the same as 4 times 3 times 2 times 1. And that's what we did in the previous example. In example 1, we did 5 times 4 times 3 times 2 times 1. So that would be written 5 factorial. Or you could have 12 factorial. Or you could have a million factorial. Okay? Now there's two ways that we can think of these permutations. We can take a number of objects and arrange those objects into however many spaces we have to arrange them in. So this is like where we have the letters A, B, and C, or the pictures on the wall, 3 pictures on the wall, and you have 3 pictures that you want to arrange in 3 ways, into 3 spots, I guess I should say. Okay, so that's what that means. That's the same as 3 factorial, and that's the same as 3 times 2 times 1. And if we had 4 factorial, which is 4 times 3 times 2 times 1, that we wrote it with 4 exclamation point, and that would be 4 permutations. So we'd have 4 objects that we want to arrange into 4 spaces. That's kind of what that means. But now you don't always have the same number of objects that you do spaces that you're trying to arrange it in. Let's say we had 6 pictures, but we only had space for 3 of them. That's when this other equation comes in, when we have n objects taken r at a time. So if I have 6 pictures, but I can only put 3 of them on the wall, I would have 6 objects that I want to arrange in 3 spaces on the wall. So then I'd have 6 factorial, but then I would do 6 minus 3 factorial in my denominator, because I can only take the 3 spaces. So think of that if I had 6 spaces, or 3 spaces on my wall, but I had 6 pictures to choose from. 1, 2, 3, 4, 5, 6. I don't know why they're smaller than the spaces, okay? But I've got 6 total options for this first spot, and then 5 for this spot, and then 4 for this spot. And then I'm out of room. I can only hang in 3 pictures, okay? So that's what that equation helps us do. It helps us take a big number and arrange them into a smaller space. So let's take a look at this next example here. Your band, pretend you have a band, has written 12 songs, and you plan to record 9 of them for your CD. So how many ways can you arrange the songs on the CD? And this is definitely a big part of the music industry, how the songs are arranged. Okay, so again, we've got 12 objects, and we want to arrange them into 9 spaces. So that means we're going to take 12 factorial over 12 minus 9 factorial. So 12 factorial, if we write it all out, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. And right now you're probably wishing you didn't have as many songs. 3 times 2 times 1. There we go. All over. Now 12 minus 9, That's 3. So our denominator is really 3 factorial. 3 times 2 times 1. So you're going to have 3 songs left over that you're not going to be able to put on your CD. Now the 3 times 2 times 1, that'll cancel here with the 3 and the 2 and the 1. So now we just have to really multiply 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. Okay? So you can actually multiply that out and we'll get 79,833,600 different arrangements for your CD. And that's probably way more than you want to actually listen to, but that's mathematically how many different combinations there could be for that CD. Now, luckily, there's a shortcut for doing this on your calculator that I can show you in class. But let's take a look at our next example here, example 4, just to make sure that we understand what this really means, okay? And we won't work with such a big number this time. So here we have 21 students in the class, and the teacher's going to pick 3 of them to be class officers. Now this happens pretty often, especially in elementary and middle school. The teacher picks students for certain roles. So you've got 21 total students, but only 3 of them, there's only spots for 3 of them. So that means we've got 21 factorial divided by 21 minus 3 factorial. So 21 factorial is still in our numerator. 21 minus 3 is 18 factorial. Now that's good because that means everything from 18 and down is going to cancel. Just like in our previous example, in our denominator here, we had 3, 3, 2, 1 for 3 factorial, so the 3 and the 2 and the 1 canceled. If I would have had 5 factorial, that would have been 5, 4, 3, 2, 1. That would have canceled. So here, I'm going to have everything from 18 and down. That's going to cancel. So that means I'll still have the 21 times the 20 times the 19, but I won't have the 18, 17, 16, and so on all the way down to 1. Okay? So this helps me save a little room here when I'm actually writing this all out. And then if I multiply, this will end up equaling 7,980 different arrangements. That's how many different ways the teacher could pick 3 students from a group of 21 students. So that's a lot of arrangements for that teacher to consider. Okay, now, whether or not you have a little calculator or a graphing calculator, you can do these on the calculator. The little calculator, they have the buttons for the factorial and the P right on there. In the graphing calculators, I believe they're in a special menu, and I put a note about it right here. If you go to the math menu and then go to the probability menu in the graphing calculator, that's where they have the factorial and then the permutation notation already programmed in. So I can show you how to use those in class. But these problems are just to make sure that you can actually do your evaluations. And if you want to type them into the calculator, you can, or if you just want to write out what they mean by hand, that's fine too. But 7 factorial, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. So if you just type in 7 and then the exclamation point in your calculator, it'll give you 5,040. So find where that factorial button is on your calculator. It's probably a second and then some other button. Depends on the type of calculator you have, or if you're using your phone, you have to find where that option is in your phone, the calculator on your phone. But make sure when you do 7 and then factorial, the exclamation point, it gives you 5,040. And then you can divide as well. So you would do 13 factorial divided by 10 factorial. You shouldn't have to put parentheses around it, but you might want to. You could put parentheses around the numerator and the denominator just to be on the safe side. But when you type that into your calculator, you should get 1,716. And then for this 6 permutation 5, you can, again, do this by hand if you would like. I mean, the directions say use your calculator, so we're trying to get you to type it into your calculator. Usually in the calculator, you have to do the 6, and then you have to do the little P button. And I think they have the NPR. I think they have the N and the R on the little button, and then you would type the 5. And then when you type that into your calculator, it should give you 720. But again, if you wanted to think through this by hand or with the equation, it would be 6 factorial over 6, whoops, 6 minus 5 factorial. So that would really be 6 factorial over 1 factorial. And 1 factorial is just 1. You're just multiplying 1 by itself. Okay? So this is really 6 times 5 times 4 times 3 times 2 times 1. All right, for part D, again, if you're typing that into the calculator, 12 factorial over 12 minus 0 factorial is what we're really thinking through here. And that would be 12 factorial over 12 factorial. Now when you have a numerator and a denominator that are the same, it's going to divide out and you're going to get 1. So when you type this into your calculator, you would do 12 and then the little permutation button and then 0, and it should give you 1. Okay, and that'll happen anytime that second value is a 0. You'll get 1. Now part E is just a little bit different because it's got a number, a fraction, that we're going to multiply by the value after we get 30 permutation 2. Okay, so when you type this into your calculator, the 30p2, we'll leave the 2 over 15 for now, and then that value that you get for your permutation is 870. Because again, if we're thinking of that in terms of our equation, that's 30 over 30 minus 2 factorial. So that's really 30 factorial over 28 factorial. So everything from 28 on cancels. So it's really just 30 times 29. And that gets us the 870. So that's the process that your calculator is doing very quickly. And then you can use your fraction button, do 2 over 15 times 870, or multiply across, do 2 times 870, and then divide by 15 times 1, which is 15. You should get 116 for your final answer. And then for part F, we just have 2 permutations here that we're subtracting. So 7 permutation 3, that will be 210 when you type that into your calculator. And then 5 permutation 2, that's going to be 20. And then you can subtract them afterwards and get 190. Now, depending on the type of calculator you have, you might be able to type in the expression or the subtraction problem just as it looks here. And the calculator might give you 190 directly, but there's no shame in evaluating one part, evaluating the other part, and then subtracting them afterwards. And again, if you have questions on how to put this into your calculator, either the little scientific ones or the graphing ones or a smartphone calculator, bring it to class and we will work through it and we will figure out how to type that in so you can evaluate those correctly on your calculator. In the next section, we're going to talk about combinations. So there's a difference between permutations and combinations. And there's a different button for those on the calculator as well. So you want to make sure that you know how to put these into your calculator. So again, these notes aren't in your book, so use your type notes from class, look at the notes online on the class website, watch this video. Your homework is another worksheet, and if you have questions, come on in and see me before school.